In today's lesson, we're going to take a look at ocean currents. As you watch the presentation, you should be taking notes on the following. What drives surface currents? What is the Coriolis effect? How do deep ocean currents and surface currents differ? How does ocean currents affect the climate? Then, upon completion of the video, consider what the world would be like if currents stopped flowing. Write a paragraph that addresses this, giving at least 3 facts to back up what you believe. So in order to do this, you need to make sure you're taking good notes as you watch. The first thing we're going to take a look at is just what an ocean current is. It can be compared to like a large river of water flowing within the ocean. Most of you have seen the movie Finding Nemo, and we see them taking a ride on the EAC, the East Australian Current, and it literally is just that. It's a body of water that moves through the ocean. Those at the surface are called surface currents. Those are easy names, but it's important to know that they are driven primarily by the wind. Surface currents carry warm or cold water horizontally across the ocean's surface. They usually tend to be warmer than those that are beneath them, and as we've talked about properties of water before, warmer water tends to be less dense, therefore it will be at the surface as opposed to colder water deeper in the ocean. Surface currents can go to about 400 meters below the surface, and they can move rather fast, 100 kilometers per day. That's about 60 to 65 miles per day. The Earth has something called prevailing winds that influences the formation of ocean currents and the direction in which they move. And if you've been at the beach before, you've heard of this. You know that there are winds that are strong and they're driving the ocean currents even along the coastline. Then there's another factor called the Coriolis effect, and this is the movement of wind and water to the right or to the left because of Earth's rotation. Not only does it drive the ocean current movement, but think about weather patterns and how weather patterns in North America tend to move from west to east. And as you look at the picture here, you can see how ocean currents in the northern hemisphere tend to do the same thing. They move from west to east across the Atlantic, and then from Europe and Africa back towards the Americas, they tend to move back from east to west. And this is just because of the way the Earth is rotating. The shape of the continents and the land masses can affect the flow and the speed of the currents. Currents form small or large loops and move at different speeds depending on the land masses they come in contact with. So think of spanning the entire Atlantic Ocean or the entire Pacific Ocean. There's going to be a huge rotation of water that's going to follow that same path. But if it's in a smaller, more confined area, there'll be a much smaller flow. Now let's talk about density currents. These are the currents that carry water from the surface to the deeper parts of the ocean. And these tend to be changed or affected more by temperature than anything else. So think of the water as it is at the ice caps, right, the North or South Pole. The water is going to become very cold, and as a result, it's going to tend to become more dense, and therefore it's going to sink. And so it's going to be forced down to the bottom. And it continues to flow that way, usually about to the equator, whereas then it starts to gain in temperature, rises, warms up, and then becomes part of the surface current again. So it's this constant cycle. This has a huge impact on our weather and our climate. You have that warm water flowing from the equator towards the pole, and so that's going to tend to keep the eastern side of the continents a bit warmer, and this would be in the northern hemisphere, and as opposed to that, you're going to have colder water from the poles flowing back down towards the equator, which will tend to make the western coast of North America much colder. And so let's take a look at that. So in the East Coast, where which is what we are affected mostly by here in North Carolina. We have the Gulf Stream. So it flows from the equator all the way up the Atlantic coast, and at about the Outer Banks it starts to head out towards more of a northeast pattern. That regulates our climate. It keeps the water warm, and as a result, it keeps the air temperature warmer here in the southeast. We talked about um, the temperature of water and how the specific heat of water tends to be very high. Therefore, the air temperature is greatly affected by the temperature of the water. On the west coast, it tends to be much cooler. There is the California current, which flows more from north to south, and it brings that cold water with it, and that keeps the water on the Pacific Ocean very cold. If you've ever been there, you can probably attest to that the water is extremely cold and doesn't make for great vacationing because it does tend to have a cooler climate. This can all be combined together and considered the Great Ocean Conveyor Belt. So we have this movement of materials and water all over the ocean. The Great Ocean Conveyor Belt is the name for the model of the large system of ocean currents that affects weather and climate by circulating thermal energy around the Earth. So again, that thermal energy is technically heat. Now with that, other things can get transferred as well. I mean, there can be solid waste that can be moved from place to place. Animals, again, we'll use that as migration patterns. They'll follow along with the with the conveyors or with the ocean currents. And here's a picture just kind of show you what that's like. It's kind of interesting that scientists believe that it takes about 1,000 years for something to complete an entire cycle. So think about how things are moving constantly through the oceans and how things are getting transported just all over the place. So in conclusion, review the things you've taken notes on. Now I need you to write a paragraph to tell me what you think it would be like if there were no ocean currents. If those currents stopped flowing, what kind of impacts would that have on the Earth? What kind of impacts would it have on you? How would it impact our climate, our growing seasons? So think along those lines.